All right, so this week's lab is going to be the Fischer Esterification. So typically you start with a carboxylic acid. In this case, everyone would be starting with the acetic acid as the carboxylic acid component, so that is a known. And then you would also have an unknown compound. It's going to be your alcohol, and we just don't know what the R group is, but there are three possibilities of what it could be, one of which is propyl, benzyl, or you can either have isopentyl as the R group on the alcohol. And therefore, when these two compounds are catalyzed by a strong acid, in this case it's going to be sulfuric acid, they will merge together to form an ester. And so you see on the ester, which is our final product, the R group is coming from the alcohol component. And based on what the ester is that you form, it will have a different smell. So some of the smells could be either peach. In that case, you would have formed the benzyl ester. When the R group is propyl, the smell of it is like a pear scent. And then if R is isopentyl, coming from isopentyl alcohol, the ester will smell like banana. And so, unfortunately, for those at home that are doing this lab online, you won't be able to smell the compound, but we will also be able to determine what our ester is based on its density. So these are known compounds, both the propyl ester, the benzyl, and the isopentyl derivatives. And so we can find their densities, and when we do a separation using our separatory funnel, we will be able to determine which ester we have formed. Therefore, you'll be able to go back and see which was your unknown alcohol. Was it propyl alcohol, benzyl alcohol, or the isopentyl alcohol?
All right, so we'll start the experiment. This is our Fischer Esterification. We have our unknown 12, so we don't know what alcohol this is. We'll just record that it's alcohol number 12. And we're going to do this under acidic conditions. So we have our acetic acid and our concentrated sulfuric acid. So we're going to mix all of these things together, and we're going to reflux the solution so that it has a chance to react over the course of an hour. So we're going to add our alcohol, and it's already pre-measured for us. So we're going to add the full contents of the vial. And we want to add acetic acid in a 1-to-1 ratio, and that comes out to about 2.75 milliliters. I'm just going to use a graduated cylinder to measure that out. And we'll do our best that we can. So, looks like we need to add a little more. Tell me when to stop, Dennis. That's about good. And we'll add that to our alcohol. And we're going to add our sulfuric acid catalyst, and it says add about 0.25 milliliters. If you think about it, that's about a quarter of a milliliter. And I'm just going to use the rule of thumb that there's 20 drops approximately to 1 milliliter. So a quarter of 20, we'll just add 5 drops to our solution. And this is catalytic, so it will be turned over in the reaction. And then my little silver dish here. It's going to allow me to add sand to it. And when I lower that round bottom into the sand, I'll be able to fill it even more. And remember, the sand is the only thing that's transferring heat to our round bottom, so we want to make sure that at least the solvent level is covered with our sand. We're also going to make sure that we don't lose any of our reagents, so we're going to add a reflux condenser. And with this reflux condenser, we're going to add some tubes on the way in from our water tap. So the water goes into the condenser and out into the sink. And this will allow any vapors that start to rise to hit the cold condenser and cool back down into the round bottom. Anytime we use a reflux condenser, it's important that we just stack the deck and make sure we don't lose any vapors. And if the vapors pass through this joint, well, it's possible that they could seep out before they hit the cold condenser. Grease lightly the top of this ground glass joint, and we'll put it in our joint and just twist it so that we get a nice tight seal. Just adding some grease to a little paper towel.
Alright, so here's the set funnel. I'm going to pour my solution from my round bottom flask in there. So what I want to do first is I want to wash it with water. So the point of this is we're going to try to wash some of the acid out of the organic material before we add our sodium bicarbonate. We got 25 mLs of water here. I'm going to rinse my round bottom flask with that real quick and pour that in. Right. You can see the two layers are forming. So I'm going to cap it, shake it, vent, let those layers separate. This might take a sec. You can see the layers starting to form. So we're going to let this separate out. We're going to drain the layers into two separate flasks. We're going to put the organic layer back in and then extract it twice with 25 mLs of sodium bicarbonate. Alright, so hopefully this is separated out enough. It's kind of hard to see, but that layer is right here. Okay, so we're going to drain that out. Alright, I took a little bit of the aqueous layer just to make sure I got all the organic stuff, because I'm going to put the organic back in. So you might be asking how you can tell if it's the organic layer versus the aqueous layer. Well, you know that you put in a lot of water, right? And you didn't have a lot of organic stuff. So it makes sense that the layer that is the biggest is going to be your aqueous layer. So I'm going to add the sodium bicarbonate. And again, I'm going to cap it. I'm going to flip it over and immediately vent it. You can kind of hear a little bit of gas escape, hopefully. There you go. You can see some bubbles happening there. We're going to flip this over. Again, let this sit. So I keep swirling it to try to get anything that's stuck to the side to kind of like come together and form a liquid so it'll fall down to the bottom. Alright, so again, I kind of have 2 layers going here. You can see there's a layer of stuff down here at the bottom. We're going to drain that out. Hopefully. You can see the droplets coming together, but they just aren't kind of forming a good layer. They're kind of sticking to the side. I'm trying to get them to come together. Let's try again. Oh. That's better. Should hopefully come out now. There we go. Okay, now we've got like a good layer at the bottom. We can drain that out. Go. Drain out the aqueous layer, and then one more time. Do the extraction. Again, 25 mLs of sodium bicarbonate. Over, vent, so it doesn't hiss nearly as much because we've gotten rid of most of the base. So I'm going to stop the recording here for a sec and give this some time to settle out so we get a good layer.